Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this first lecture of Module 11 on Geomorphology of Sea, Sea Source, Shoreline Engineering Geology, Hazards and Mitigations. In previous lectures we have discussed about landslide and earthquake and induced seismicity, which are natural hazards and anthropogenic hazards. Now one of the hazards also associated with seacoast, that is erosion of seacoast. In this lectures we will going to elaborate about seacoast features and agents. In these lectures we are going to elaborate about sea source, features and agents. Regarding this, we are going to cover about introduction related to sea and seacoast, then the sea features, then classifications and agent. Friends, as you know, the seas of span across several kilometers and cover 70% of Earth's surface. The shape of the area nearby these sea zones are shaped by different processes carried out by ocean waves and currents, and they shape the inland surfaces of the earth, including their floors to a large extent. The geological work of sea are responsible in several ways for changing the earth landform of the area associated with sea. You can see one view taken from the Kanyakumari area near this shore area and shallow sea. Regarding different features, first we have to define about the shoreline. The shoreline is nothing, it is the boundary lying between the seawater and land. The shoreline can also recognize as coast or coastline. Sometimes the peoples have defined coastline slightly lesser zone than the shoreline. It is the area where the land meets the ocean or line that forms the boundary between the lands and the coastline, means covering the sea or oceans. Oceans we generally refer for the deep water large body, sea in general representing slightly lesser for the extents. The shores are influenced by topography of the surrounding landscape as well as by water induced erosional and depositional work carried out by waves, currents and other forces. The earth has approximately 6.2 into 10 to power 4 kilometers of shoreline throughout the world as a general convention, and the sea shores are important zones in natural ecosystem consisting of beach, consisting of littoral zones, freshwater, estuarines and wetlands, and the wave protected salt marshes, mangroves, seagrasses, etc. You can see this boundary represents the shoreline. In this direction we are having land mass. So the boundary lying between seawater and land we are going to recognize as shoreline. Shoreline is also recognized as coast or coastal line in some cases. However, in some cases the coastal line is more close to the land in comparison to the shoreline. The shores are influenced by topography of surrounding landscapes, as we have already discussed, or water-induced erosional work carried out by waves, currents and tides. And an estuary is a partially enclosed coastal zone of brackish water or mixed water, partially fresh water carried out by rivers and partially seawater in mixed nature with free connection to the open sea. Sometimes we are getting some enclosed zone also having mixed water, fresh water and saline water, but there is no connection with sea. Estuaries form a transition zone between river environment and the marine environment. The wave protected are they harbor the salt marshes, mangroves and seagrasses, as we have already described as example. And the typical example of tropical coast known for rich coral reef between this depth ranging from 1 to 50 meter water or below water. A shore is the wider fringe that is geologically modified by action of body of water in past and in present, while the beach is at the edge of shore representing the intertidal zone. Here in this figure you can see the different parts of oceans and coast. Broadly, if we are going to see, this region is fully covered by oceanic water, and this region partially land and partially oceanic water, and this land is away from this zone. Then further the coastal area we are going to divide as a coast close to the land area dominated by different dunes, and the beaches of certain extents and up to extending up to this region as a beach face. In terms of shore, if we are going to categorize this zone, whole zone, then we can able to categorize as a backshore and foreshore. The backshore, foreshore depends on the water extension zones, and the coastal area we are considering here the shore face zones which indicate and mark as the boundary between the onshore and offshore. This whole zone we are going to recognize as onshore, and this onshore area can be divided into several zones based on the characteristic of land area as well as the ingress of water and different actions of waves, currents, etc. The land away from the coastal zone is recognized as hinterland. So this shoreline slightly in this figure you can see the shoreline is slightly this shoreline is slightly different than the coastal line marking only land area. The shoreline is having some ingress of the water inside this. In addition to this, if we are going to recognize different features and try to categorize different features of sea, then we can here see we have already categorized this zone in form of backshore, foreshore, coastal line, marker coast zone, shore zone, etc. This coastal zone, or in another word shore zone, collectively having some beaches, having some estuaries dominated by mangroves, grasses, etc. depending on the nature of water. Then this zone we are going to also recognize a zone influenced by tides, and this zone also considered as the intertidal or littoral zone. It located from high tides to low tides zone. After this we are going to enter the land area which lying below the water up to shallow depth ranging from 0 reference to 200 meter, recognized as continental shelf. So located from low tides to the edge of shelf is recognized as continental shelf. Then this break up to the abyssal break is recognized as continental slope, and then we are having some flat area recognized as abyssal plain. Then the sea floor is dominated by number of trenches and number of ridges. Some of the ridges may extend up to level of water, some above the level of water is recognized as oceanic ridges. So first we are going to see all this and then going to elaborate one by one. The continental shelf located from low tides to the edge of the shelf, and the continental slope where the sea bottom slopes steeply to the deep sea called as a sea or sea floor as abyssal zone, and the break having higher slope is recognized as continental slope. Abyssal plain, the bottom of the ocean where it extends as a flat in nature, recognized as abyssal zone. So in detail we are going to elaborate about the intertidal or littoral zone, and this zone where the ocean meets the land is the intertidal zone. This zone is divided into high tides and low tides zone depending on depth of water at which these tides occur. Above the tidal zones we have some beach. Then the continental shelf we are having this low slope zone which is extended from this low tidal zone to this edge of continental shelf and ranging in depth below the surface 200 meter. Then the slope is extending. This floor is steepen further down along the continental shore. The floor steepens further in comparison to continental shelf and extended several kilometers inside the water. The depth of this continental slope ranging from more than 200 to here 2000 to 3000 meter. Then abyssal zone is a flat zone. Actually, the term abyssal is taken from the Latin words abyssalis. Abyss means the bottomless or extremely deep system. Therefore, this abyssal zone is located at higher depth. It extends from the continental slope toward the deep water in flat nature, ranging from 4,000 to 6,000 meter in depth. The abyssal zone is also known as abyssopelagic zone, is one of level into which the oceans are divided, and it is found between 3,000 to 6,000 meter below the surface. An abrupt marginal slope separates it from the continental slope, and the clay and silt deposits are the chief sediments accumulation on this abyssal plain. It lies between the continental rise here, continental rise, the mid-oceanic ridges as flat plains. Here the trenches are the deep, ranging up to depth of the 10,000 meter, more than 6,000 meter to 10,000 meter, and the number of ridges are at shallow depth. The sediments of abyssal zones are chiefly transported by turbidity current, and the turbidity currents are responsible for transportation of sediments from edges of continental shelf onto the ocean floor. Such type of deposits we are recognizing as turbidites, are mixed and complicated in nature. Besides abyssal plain, below the higher depth, we have ridges and trenches as specific features of seafloor, and the ocean floor contains several ridges and volcanic peaks. We can see the number of examples in Pacific Ocean. Some volcanic peaks exposed even above the sea, and good example is Hawaiian Islands. The mid-Atlantic ridge is a ridge system, represents at the middle of the ocean, recognized as mid-oceanic ridges, and these ridges are associated with diverging plate boundary and formation of new crustal material as a new plate. The trench present in oceans or sea are very steep gorges in seafloor, and we have one excellent example of Marina Trench, very deep in nature. Several large trenches are present. Several large trenches are present in the ocean near the Hawaiian Islands, because the Hawaiian Islands are elevated part, and this elevated parts countered by the depressed part. If we are going to elaborate this coastal zone here offshore, the coastal zone is a beach, and beach is consisting of both backshore and foreshore, and this beach is here on upper side. Landslide is dominated by the dunes, and this zone we are going to recognize as coast. Although sometimes we are considering this coastal area up to this, but this coast zone is recognized from the backshore up to the land area dominated by dunes. So this is one features about the sea. You can see one view on the map about the Marina Trench. The work of sea is making the coast in modified shapes time to time, and the zone representing the coast is changing in topography with respect to time, depending on the nature of waves and currents going to interact with the coast and the nature of rocks and material present in land area. The coastal land includes cliffs and shores, which are areas between low water and highest storm water waves. The work of sea is the sculpturing of coasts or modifying the shape of coast. The coastland includes cliffs and shores, which are the area lying between low water and highest storm water waves. This is dominated by sediments we are going to recognize as beaches. When the ocean water is in violent nature or violent in motion, it scores or erode coasts around the world and also deposited sediments from one place to another place. The eroded materials are deposited on the land at the fringe of the ocean water, and that is the coast, and along rocky shore the water laden with the rock fragments batters the landway. However, the fragments transform the cliff fringe coasts are deposited gently on the shores to raise beaches with sand, gravel and shingles. Hence, most coast advance or retreat depending on the nature of waves and currents going to interact and the nature of rocks or material present in land area. If we are going to see the principal agents, then in major way the waves and currents, two agents are playing major role in erosion and modification of the coast. However, the tides are also going to help. The waves, as you know, undulation set in motion mainly by wind. The wave energy increases with wind energy as the wave is formed due to interaction of seawater and wind. Here we can see for our elementary idea about the wave height. The wave height is a ranging distance between the crest and trough of a wave, and the half of the height is recognized as amplitude. The lateral distance between two crests is recognized as wavelength, and the crest is recognized as the maximum point or maximum curvature point, and the trough is just opposite to the crest, lying below, here lying above and here lying below. This represents the direction of movement as wave propagation. The oscillatory waves, a type of wave that are far away from the shore in the ocean water, and in these waves the movement is up and down and the vertical in nature. If we are going to see about the velocity of waves are function of height, function of wavelength, function of the depth of water, and function of the orbital motion of the wave particle. In open ocean or sea, waves pass through the water without moving it forward, and when wave approach towards the coastline, here when the wave approach towards the coastline, then the surface of the ocean floors or the land lying below the water is going to drag the waves back. Due to such, and the wave is going to move towards the land side. This wave is going to here interact with the coast, and the coming wave is going to overlap this returning wave and form currents. So when the wave approach toward the coastline, their bases drag on the ocean floor, whereas the crest continue to move toward the land side. Ultimately, waves collapse over themselves in association with coming waves and returning waves. In case of storm, the waves behaves in two distinct ways as an agent of erosion. So when this wave is going to move forward, then crestal part is going to sweep towards the land. However, due to drag effect, this lower parts is slightly away from this crestal zone, and the same times next wave is coming. Due to such type of complicated interactions, the finally wave is going to collapse. Here you can see the drag forces, and here if wave is here, the crest is moving toward the land. However, the trough is slightly extended toward the offshore side. If the shore is made up of rock strata, you can see here the made up of rock strata, the high waves spirited against the shore made up of rock strata with adequate force cause fragmentation of rock strata. Later on, this fragmented part is further rubbed or further fragmented and form in smaller fragments, then further reduction in size and taken from the returning waves towards the offshore. If this zone is made up of soil, then sometimes the waves is going to cut almost major part of the shore zone made up of loose material, sandy material, soil, and in certain cases the whole of the shore zone finished its existence. As far as the currents are concerned, we have already discussed here when this wave is going to move toward the land and there is a drag force due to collapse of these waves, there is a generation of currents which going to move toward the offshore side in form of currents and going to cut varieties of materials and transport toward the higher depth. The currents can be divided broadly as undertow currents based on the presence below the water level, and the density currents which carrying the sediments. If it moves along the longshore, then it is also called as longshore currents or littoral currents. So one by one we are going to discuss about the currents and different type of currents. Ocean waves hits the shoreline and produce currents that move back towards the ocean and carried major erosional work and transportation of sediment toward the ocean side. The longshore currents, as the name indicate, it is along the shore. The waves act an angle on the shore, not normal to the shore line, and this creates a net flow of water called as longshore current. And it is flowing along the coastline parallel to the shore within the zone of the waking waves, therefore recognized as longshore currents. Besides these longshore currents, we have undertow currents. As name indicate, undertow currents are underwater currents. It is the underwater current that moves offshore while waves reaches the shore. It is a return flow compensating for the onshore directed average transport of water by the waves in the zone above the wave trough, and the flow velocity of such currents are commonly robust in surf zone, where we are going to get the breaking of waves. The surf zone is categorized by water of shallow depth, and the waves are high due to swelling. The waves are high due to swelling. Retreating currents below the approaching waves is known as underwater current, and it results fragmentation of rock which move forward and backward and resulting reduction in size. And undertow or underwater currents occurs everywhere underneath the shore when the wave approaches the shore, whereas the rip currents are localized narrow offshore currents occurring at certain locations along the coast. There is a difference between the undertow currents and rip currents. This process results reduction in size of fragments and transportation of materials from shallow to deeper depth, and responsible for major modifications in coastal zone. The density current, as the name indicates, depends on the density of water, and these are the suspension currents that transport sediments by suspension, mainly finer material. And these currents may carry particles over a long distance of several kilometers and from the mouth of large river flowing into the ocean. These can be also observed in case of the dam reservoir. You can see here the undertow currents, the returning currents. When the wave is going to reach the shore, then due to drag, the trough part is slightly away from this moving waves, and the next coming wave is going to collapse along with the waves and forming current, that is the returning currents. Beside these waves and currents which are going to contribute maximum in erosional work, the tides are also partially modifying the shape of coastal zone. The tides are the rhythmic rise and fall of ocean water caught by gravitational pull of moon and the sun. It can be observed along the shoreline. The coinciding with the storm waves, the highest tides affect the highest level of the ocean shore, and a tide is the bulge of the water on both sides toward the moon side as well as opposite to this moon side as a counterbalance. This result in two high tides and two low tides every day as the earth rotates through the worlds, and tidal heights vary throughout the month due to the change in position of the sun, moon and the earth. The tides can be divided in two types, spring tides and neap tides. Spring tides occurs when the earth, the moon and the sun are all in alignment, and that is under the greatest gravitational pull during the full moon and the new moon phases, and this type of tidal action is ranging at a maximum and the tides of the highest height. The neap tides is relation at right angle. They occurs when the sun, moon and earth are at right angle, and the tidal range is a minimum at the neap tide since the gravitational stresses are not in aligned pattern. Besides this, we can see the diurnal tide patterns consisting of one high tides and one low tides per day. However, the semi-diurnal tidal patterns consisting of two high tides and two low tides within a 24 hours period having approximately equal heights each on each tidal date. However, the mixed type of tidal patterns in these two high tides and two low tides each day represents the distinct differences in their height. So, in contrast to the semi-diurnal type, the height of the high and low tides of a mixed tidal patterns vary significantly. Friends, this material I have prepared from different sources from the website, taking this American Heritage Dictionary for defining the coast and the definition of the coastline published in 2015 by the Merriam-Webster, then partial supports from the book of Engineering Geology written by Gangopadhyay in 2013, and partial supports from the other engineering geological book written by Well F.G. in 2007, and the Kasavulu on the textbook of engineering geology written in 2016. Beside this, the papers written by Venson in 1984 and the McMahon et al. In 2006 and the Pitchard in 1967 are gratefully acknowledged. As far as conclusion is concerned, the sea covers about 70% of the earth's surface. The seashore is the boundary between the land and the oceans or sea as per definition of the oceans presented in 2015, and the sea features are divided broadly as Nearctic zone and oceanic zone, or the oceanic zone and the coastal zone, and the waves and currents are the principal agents for modifications in landscapes, and the tides are also partially contributing in formation and modification of lands nearby sea area. Dear friends, in this class we have elaborated about general features of sea or oceans and the agents responsible for modification in coastal zones. Thank you.